What's up everyone, this is LeetCode 70, climbing stairs. You are climbing a staircase, it takes n steps to reach the top. Each time you can either climb 1 or 2 steps, and how many distinct ways can you climb to the top? So, I kind of want to draw this out in a comment just kind of to, for you to understand what basically the problem statement is, right? So, we are climbing 1 or 2 steps, right, up to the nth step, and we have to find out how many distinct ways we can get there. We can either climb one step or two steps at a time, right? So, for example, let's say n is 1, right? How many ways can we get from the floor up to step 1? Well, that would just be one step, right? We just climb up one step and we're already at n. Now, what if n is equal to 2? How many ways can we get to the second step? Right? How many distinct ways? That would be two ways, right? Because we can go one step, or we can go from the ground 2 steps, right? So there's 2 ways to climb up to the second step, or 2 distinct ways, I should say. Now, what about the third step? How many distinct ways can we climb to the third step? Well, 3, because we can go one step, or we can go 1 step, 2 steps, or we can go 2 steps, 1 step, right? So there's 3 distinct ways to climb up to the third step. Okay. What about the fourth step? Well, there would be 5 distinct ways, right? We can go 1 step, 1 step, 1 step, 1 step to get to the fourth step, or we can go 2 steps, 2 steps, or we can go 2 steps, 1 step, 1 step, or we can go 1 step, 1 step, 2 steps, or we can go 1 step, 2 steps, 1 step, right? 5 distinct ways. Now let's do, this will be our final example just because obviously the distinct number of steps are going to increase as n gets larger, right? So when n is equal to 5, there will be 8 distinct ways to get to the 5th step, right? We can go all 1 steps, or we can go 2 step, 2 step, 1 step, or 1 step, then 2 steps, and then 2 steps, or 2 steps, 1 step, 2 step, right? You get the point, right? Now, when we look at this, we might notice a pattern, right? We might notice that for a given n, if we take if we take the result from 1 step below and 2 steps below, right? Their sum is going to equal the distinct ways for n minus 1 and n minus 2. The sum of that is going to be equal to the distinct number of steps for n, right? What I mean by that is you might notice a pattern which this formula kind of shows, right? Which would be this, right? To get the number of steps at n, we can take the number of steps, the number of distinct steps from the previous step, and add that to the number of distinct steps from the step 2 steps below, right? Meaning steps of n is equal to step of n minus 1 plus steps of n minus 2, right? And so because of that, this problem really is just a Fibonacci sequence, right? Okay, so this problem, I'm not gonna lie, the first time I ran into it, it was a little bit difficult for me to kind of see the pattern, right? But this is kind of an introductory problem to dynamic programming. So I just want to make you aware of that because it is something that you're going to have to practice if you're not good at. Dynamic programming can be a little bit complicated, especially as you move on to harder problems where you have to basically solve the subproblems to solve the to solve a problem, right, you have to solve the subproblems. And this is probably the easiest dynamic programming problem you'll run into. And it'll only get harder, so really, I don't have much advice other than make sure you go out of your way to study dynamic programming. This is an introductory problem, but they definitely get way, way harder. When you see the pattern in this one, right, it might be pretty simple, but it can get pretty complicated as you move on to harder problems. So yeah, just want to make you aware of that. But now we see the pattern, right? So first of all, remember for one step and two steps, well, if n is less than or equal to 2, we're just going to return n, right? Because the only way to get to the first step is take one step. The only way to get to the second step is either take one step, or two steps, right? So for the first and the second step, n is just going to be equal to the number of distinct steps. Same with 3, but I'm not going to do this for 3, just because of our formula, right? Steps of n is equal to the steps of n minus 1. When I say steps, I'm talking about distinct steps, right? The only reason I'm not going to make this like this, right? I'm going to keep it like this, is because I want this formula to just be starting at basically 3. So we're going to basically work our way up from 3 up to whatever n is, okay? We're going to do this iteratively. So we're going to, let's set our n minus 1, right? Our n minus 1 is going to initially be at 2. Our n minus 2 is going to be 1, okay? Now we're going to start at 3, right? And we're going to go up to n. So our current n right now, we're just going to set to 0. So we're going to say for I in range 3, and we're going to go up to not n, but n plus 1, right? Because this isn't inclusive, right? If we do n, it's only going to go up to 3. It's going to go from 3 up to, and it's going to not include n, right? Because it's not inclusive. So we have to do n plus 1 so it actually, the loop executes from 3 up to and including n, right? That's why we do n plus 1. So we're going to say our current n is equal to n minus 1 plus n minus 2, right? Like that formula I just showed. Okay, that's going to get us the steps of the current n. Now we need to, right, let's say we have something like this. Steps of 2, steps of 1, right? Pretty simple. But what if we have to go up to like, if n is like 5, right? Well, we're going to have to do steps of, we're going to have to do step of 3, or sorry, steps of 4 plus steps of 3, right? But when we're going up from 3 up to 5, we need to basically, these are going to have to be changed, right? Right? They're not going to be 2 and 1, right? This distinct steps of 2 and 1 aren't going to give us the distinct steps of 5, okay? So we need to shift these variables as well. So our new n minus 2, is going to be the n minus 1, right? Because n minus 2 is going to move up one step. And our n minus 1 is also going to move up one step, right? Which would be the current n, right? Yeah. Does that make sense? Right? We calculate the current step of n, or whatever, or not n, but whatever the I is, right? Let's say it's whatever the I is. We calculate that by taking n minus 1 plus n minus 2. That's the current distinct steps for that particular I. then the n minus 2 moves up one step, and then so does the n minus 1. So the n minus 2 goes up to the n minus 1, and the n minus 1 goes up to the current n, which would be the I, right? I'm saying current n, but current n really is just referring to the distinct steps for I, right? So that's basically going to continue executing up until we get to a current number of, it's going to go up to n basically, right? And so we keep track of the distinct number of steps of these two basically to calculate whatever n is, okay? Then we return current n. That should work. Whoops. In range, my bad. Yeah, it's omitted. I just didn't run the test cases, so that error didn't change, but should work, right? So I'm gonna just, in case I didn't explain it well enough, right? This is our initial. This is our initial n minus 2, right? And this is our initial n minus 1, right? So we use these two to calculate this n, or rather this I. But let's say we're going up to n is equal to 5, right? Let's say that's our input, n is equal to 5. So we use this and this to calculate the distinct number distinct number of steps of n is equal to 1 and n is equal to 2. And again, these are pretty simple, right? The n is equal to the distinct number of steps for these two, right? Which is our starting values. Okay, so we add these two to calculate the distinct number of steps at I, which currently is 3. So that would be so distinct number of steps at I when I is equal to 3 is 3. So now this is now n is equal to 2 is our new n minus 2, and this n is equal to 3 is our new n minus 1. Okay. Now, when we go up another I in our loop, right? When we're at n is equal to 4, this is going to be our new n that we have to calculate. So we're going to use this distinct number of steps. Here is going to be 2. Distinct number of steps here is going to be 3. We're going to use that. Take the sum. Distinct number of steps at n is equal to 4 is going to be 5. Okay. Now let's change the n minus 1 and n minus 2, right? This is going to be our new n minus 2. It's going to be our new n minus 1. Now when the I changes, right, in our loop, we get to here, we're going to use this n minus 2 and this n minus 1. We're going to take the sum, right, for this n, and that's going to be equal to 8, right? So if n is equal to 5, that's the end of our loop, right? Because this n plus 1 is not inclusive. This loop goes up from 3 up to and including n. So if our function is passed n 5 as an input, right, we would return right here, we would return 8. Okay. Again, just want to go through an example. You guys know how I do these videos. I go through examples. I do it slowly, just so you make sure so I can make sure that you understand what our loop is doing, right? So we use the first we use the distinct number of steps at n is equal to 1 and n is equal to 2, right, to set our values here, and then we iterate from 3 up to whatever n is. Okay, and we use these variables to basically keep track of what the new n minus 1 and n minus 2 is, and then we take the sum, and we keep doing that, right, in our loop up until we get to whatever n is, right? That's all this formula is doing. Except we're not technically working backwards. We're going forwards, right? Right. So it's not like we're technically You know, because recursively, when you look at this formula, right, you would do something like steps at 4 plus steps at 3, right? Then you would go into the 4. What is the for this 4? What is steps of 3 plus steps at 2, right? We're not doing it recursively like that. We're just working bottom up, right? We're working iteratively, right? We're working from the bottom of the staircase all the way up to n, rather than working from n all the way to the bottom of the staircase. And there are different ways to approach dynamic programming problems, because you can do it bottom up or you can do it top down, but we're just using a bottom up solution. So yeah, again, I just wanted to. I know I'm kind of over explaining things, but if you're new to dynamic programming, it can be a little bit confusing. So I just want to make sure that I am explaining things to the best of my ability. I think I did an okay job. If you're still confused, you can leave a comment. But yeah, dynamic programming can get very, very hard, especially as you do more difficult problems. This is just an introductory problem into dynamic programming, so make sure you keep practicing and you know studying the topic, because it will get a lot harder. And I know that from experience, because I've done some of those hard problems, and they're very difficult sometimes to approach. The problem statement might make sense, but the approach is very difficult to come up with. So it's something that you should continuously practice. Anyways, sorry for the long video. I just wanted to over explain things, make sure you understand. And yeah, I'll see you in the next one.